Hey, grade 11s. I'm just going to be going through this question, but the last two parts where it's accelerating up and down. Um, in this question over here, I define my positive y as up, as shown over here. So the difference now, what I'm going to be doing is that I'm going to be defining my positive y as down. That's up to you how you want to define your positive y or x direction. You choose at the beginning, but the only thing is that you want to make sure that you're being consistent throughout the entire steps. So we're going to define this as positive y down. And to start off, we're going to have to write our net formula down. F net equals to, in this case, gravity is going downwards, so that's going to be positive Fg. And normal force is acting in the opposite direction, so it's going to be minus Fn. It's going to be the same thing here. There's going to be no difference. So net force equals to force of gravity minus normal force. Now, we know from Newton's second law that net force equals to mass times acceleration. Okay? And then from 4.1, we also learned that gravitational force is equal to mass times gravity minus normal force. It's going to be the same thing over here in this situation. Now, from the question, we know that the mass is 50 kilograms, so we can plug this information in. Now, the difference here is that because we've defined our positive y as going down, the elevator is accelerating up. So the way we would write this down is that this would be 2.2 meters per second square up. But because everything is in our down direction, we're going to say negative 2.2 meters per second square down. So we're going to plug this in. So it's going to be negative 2.2 equals to mass, which is 50, multiplied by gravity, 9.8, minus normal force. So 50 times negative 2.2, it's going to be negative 110. And we're going to bring this onto the other side. So it's going to be equal to negative 490 is equal to negative Fn. So the negative for the normal force has to stay. So that's not going to disappear. So now we got negative 600 newtons going down equals to normal force. Now you can rearrange this. Now we can say that this is going to be positive. And if I change this to positive, then now this becomes up. And the number still stays the same. It's still going to be 600 newtons going upwards. And this has to make sense. The reason is because our normal force over here, sorry, let me just change the highlighter. Our normal force is going upwards. So in terms of that, our 600 newtons has to be directed upwards because our normal force has to be in the up direction. Now let's try the other question over here. So we have mass times acceleration, 50. And the acceleration now, because it's accelerating downwards and we've defined down as positive, this is still going to remain positive 3.0 equals to mass, which is 50 times 9.8 minus normal force. So 50 times 3.0, 150. And we're going to take this to the other side. So now this becomes negative 490 is equal to negative normal force. So we get, in this case scenario, we get 150 minus 490, which is equal to 340 newtons down equals to negative Fn. Now, because there's a negative Fn here, we want to get rid of it. We just want normal force on its own. So this is going to be equal to negative 340 newtons down. And now, at this point in time, you can change the negative to a positive and the down to be up, in this case scenario over here, equals to normal force. And this would still remain 340 newtons. And once again, these two have to make sense. These should be defined as positive going upwards because our normal force is acting up in the up direction. I hope this helps. Thank you.